Let us have a look at the next question, that is question number 18. So here we are given x1, x2, x4, that is random of size 4. So here one information is provided, that is n is equals to 4 and n theta 1 distribution with theta is unknown parameter. So we are given sample mean and g theta is given as theta square plus 2 theta and L theta be the Cramer-Rao lower bound on variance of the unbiased estimator g theta. So now first of all, what is the CRLR of g theta? The formula for this is g dash theta square by L theta. Now L theta is the I theta. Okay. Now I theta is the information about the theta. Now so g dash theta whole square by I theta. Now g dash theta is basically derivative of g theta. So what is g theta? So g theta is equals to theta square plus 2 theta. So this is 2 theta plus 2. Correct? Now for I theta is equals to basically the formula for this is expectation of delta to log theta by this is log L by delta theta square, right? Now in order to find out I theta, so what we have to do is we have to first find out the log L. So L is equals to 1 by sigma root 2 pi whole to the power n e to the power minus of e to the power minus half summation xi minus theta by sigma whole square, right? Now sigma is equals to 1, so that is L is equals to 1 by sigma. Sigma is not a 1, so that is root 2 pi n e to the power minus half summation xi minus theta whole square, correct? Now log, let's take log on both sides. So if we take log on both sides, so we have log L is equals to minus n log root 2 pi plus minus, we have the power here, that is half of summation xi minus theta whole square. Now if we take the derivative with respect to theta, so we have delta log L by delta theta is equals to, so this is 0 and this is minus of 2 by 2 summation xi minus theta. Now 2 gets cancelled, so this one we have is summation xi minus n of theta. So from here we get delta log L by delta theta. Now let us take the second derivative of this, so that is delta 2L by theta square. So this is 0, so I have minus n, right? So that means here I theta, the value is equals to minus of expectation of minus n, so that turns out to be n. Now if we put this value in the our Cramer-Rao lower bound formula, that is g theta square by I theta, so I have 2 theta plus 2 whole square by 4, correct? Because obviously n is equals to 4, the sample size that is given in the question is 4. So here if I take common, so 4 by 4 is taken common, so theta plus 1 whole square. So the answer here is theta plus 1 whole square. Now so this part is true, right? Because if we look at the options, this is true, but we have to find out which one is false. So we have to check the remaining, correct? The next B option, that is x bar plus e to the power x bar, is a sufficient statistics for theta. So this is very clear from the property of sufficiency that this option is also true. So that means from the following options, this cannot be the answer and this cannot be the answer. Now let us check option C, that is 1 plus x bar whole square is the uniformly minimum variance unbiased estimator of g theta. So we have to find out MVUE for g theta first in order to prove this right or wrong, correct? So let's solve this. E of x bar is equals to mu, which is equals to theta, and variance of x bar is equals to sigma square by n. So from here, if we apply the formula, then E of x bar square is equals to, this is sigma square by n plus theta square. Now sigma square is 1, n is 4, so this is 1 by 4 plus theta square, correct? Now therefore we have to find out for E of x bar whole square, right? So that is E of 1 plus 2x bar plus x bar square. Now that is basically 1 plus 2 of ex bar plus e of x bar square. Now let us put down the values. So that is equals to 1 plus, now ex bar is 2 into ex bar, right? So that is basically 2 theta plus this is 1 by 4. Ex bar square is 1 by 4 plus theta square. So here we get 5 by 4 plus 2 theta plus theta square. Now this is our g theta, but we have one extra term, that is 5 by 4. So for this to be unbiased, I need a e of 1 plus x bar whole square minus 5 by 4 is equals to g theta. So only 1 plus x bar square is not the unbiased estimator, but it is a biased estimator. So that means we have got our incorrect statement, and that is option number C. So our incorrect statement is the correct answer, which is option number C. Next question here is question number 19 from IIT JAM 2023 question paper, MS question paper, right? So now let x1, x2, xn be a random sample from the population having the probability density function f x mu, half of e to the power minus x minus 2 mu upon 2 for if x greater than 2 mu, 0 otherwise. So from this we can say that this is basically our two parameter exponential, that is e to the power x minus alpha by beta minus 1. Okay, that is the PDF. So basically here alpha is equals to 2 mu and beta is equals to 2. Now by consistency we mean that as n tends to infinity, the variance should converge, right? That is the definition we have studied. Now in order to do that, so let us just find out the following. So now here e of x is equals to 2 mu plus 2. Okay, now what we have to find out here is basically first let us take this, that is t1 is equals to x bar plus x bar minus 2 by mu. So we have to calculate e of t1. Now e of t1 is equals to e of x bar minus 2 by mu, that is half of this is 2, so that is half of e of x bar minus 2. So now first we need to know what is e of x bar. So e of x bar is equals to 1 by n summation e of xi. Now what is e of xi? That is 2 mu plus 2. So 1 by n summation 2 mu plus 2. So n of n gets cancelled, is equals to 2 mu plus 2. So we can put it here half into 2 mu plus 2 minus 2. 2 gets cancelled, 2 gets cancelled. So here we get et1 is equals to mu, that is as t1 p to mu as n tends to infinity, correct? This is as per the weak law of large numbers. So it is a So now let us find out the consistency of the second estimator. So here x1 means we have to find out the MLE. So here MLE of mu is x1. So MLE of 2 mu will be 2 of x1, right? So now let us write down the second estimator that we have, that is t2 is equals to n x1. Sorry, here there's a mistake. That is, this is x1 by 2. So 2 mu is equals to x of 1, right? So now here this is n of x1 minus 2 by 2n. So if we put the value here, the MLE estimator, that is 2 is equals to n into mu into 2 minus 2 by 2n. So that is 2 is equals to mu minus 2 by n. So now here this is very clear that as n tends to infinity, t2 tends to mu. So it converges. And again, according to weak law of large numbers, t2 is consistent. That means t1 is also consistent, t2 is also consistent. So both t1 and t2 are consistent is our correct option, that is C. The next question in front of you is given that let a and n greater than equals to 1 be a sequence such that a1 is equals to 1 and 4 of an1 plus is equals to given this. So n is equals to 1 to up to infinity. Which one of the following is true? Now in order to understand the monotonically increasing or decreasing function and whether it converges or not, let us first try to find out the following. That is, suppose this is we have a1 is equals to 1. So from here we can write a2 is equals to root over 45 plus 16a1. So 4a2 is equals to root over 45 plus 16. 4a2 is equals to root over 61. So a2 is equals to root over 61 by 4, and this is definitely greater than 1. So this is convergent. So this is monotonically increasing. This implies monotonically increasing function. Now in one case of monotonically increasing function, we know that limit as n tends to infinity, a to the power n, an tends to L. Also when limit n tends to infinity, a to the power n plus 1 till tends to L. That means this is L, this is L, put L. Now let us try to find out the value of L. That is, what is the value that it will converge to, right? So let us write down the equation here, that is 4L is equals to root over 45 plus 16L. Now let us take square on both sides, so we will get a quadratic equation, that is 16L square is equals to 45 plus 6L. So that is 16L square minus 6L minus 45 is equals to 0. So now if we try to take the middle term here, that is the middle term factor will be 16L square minus of this L minus 45 is equals to 0. Now the question is how should we factorize it, right? Right. Okay. Oh, there is a silly mistake here. This is 16, right? So this is 16 and this is 16. Now we can factorize it, and we will get 30 minus 20. 30 minus 20, 16 minus 16, and 30 into 20, that is 45 into 16. Yeah. So now let us take the, this is 36. So now let us take the middle like common terms. So that is basically 16L square minus 36L plus 20L minus 45 is equals to 0. Now 16 and 36. So if we take here 4L as common, we get 4L minus 9 plus, again if we take 5 common here, so we get 4L minus 9. So 4L plus 5 and 4L minus 9 is equals to 0. So from here we have L is equals to minus 5 by 4 or L is equals to 9 by 4. Now L cannot be negative, so that means the value of L is 9 by 4. That means it is monotonically increasing function and converges to 9 by 4, and the answer is B.